Hey everyone, it's Bradley Bush again with another algebra video. Today we're going to talk about expanding logarithms. Our to-do list for today seems a little bit long, but it's going to go by pretty quickly. First, we'll talk about some properties of logarithms because we can't really know what we're going to do if we don't have some rules. And we'll do some simple examples of expanding logarithms. Then we'll go a little bit harder with our examples, and then we'll talk about a summary. So I'll just show you the list of all the rules in a condensed form. So if you maybe want to take a screenshot or have them in a condensed one single spot to write them down, then you can. So let's start. Properties of logarithms. So here's our first property right here, number 1. And the property itself is in the green. Nope, that's not green. Some of you are like, I'm colorblind. The yellow box right there. So the property says that if you have a logarithm of any base, here they just call it base b, and you have a product of two things inside the logarithm, you have an m and you have an n, those two things are just real numbers. So by the way, I know they're real numbers. I should say they're positive real numbers because of this note I have up here at the top. I should probably make a little comment right now. This little E looking thing means element of, or in other words, it belongs to the group of something. And the interesting looking R with a plus means the positive real numbers. So M, N, and B are all positive real numbers. The only other restriction we have is that B cannot be equal to 1. So there we go. So we know M and N are just numbers. And although we could have expressions for m and n, but we won't talk about that really in this video. So we have a log of some base b, and we have an m and an n multiplied together. In other words, we have a product inside the logarithm. That's why this is called the product rule. We can transform that, or we can expand it, or we can kind of simplify it into two different logarithms, both with the same base. B is the original, and the m goes into the first logarithm, and the n goes into the second logarithm. So it's actually fairly simple. Let's do an example right here. If we have log base 4 of 2 times 5, then first let's identify each of the items, b, m, and n. So the b is the 4, the m is the 2, and the n is the 5. Now we literally are just following the example here. The property, the rule. So we have log base 4 of m, which is 2, plus log base 4 of 5. So we think we're done because we have followed the rule perfectly, but we have one other item. This can be simplified even further because really what it's asking us is 4 to what power equals 2, and we know that's 4 to the 1/2 power equals 2 because the square root of 4 is 2. And the 1/2 power is the same thing as a square root. So this quantity is really the same thing as 1/2. So if we add that, 1/2 plus log base 4 of 5, then we can say we are done. No problem, right? Let's move on to another example then. How about this one? It's called the quotient rule because inside the log here we have something divided by something else, which is a quotient. So the way that we're going to use this rule here in yellow is we can expand this or change a more complex logarithm into two simpler logarithms by taking the base. We'll keep the same base. The base is b. Both of these have the same base b. And the m, which is in the top, goes into the first log, and the n, which is in the bottom, goes into the second logarithm. And we're done. So here's our example. Log base 4 of 2 divided by 5. If we want to identify each of these quickly, each of the parts, there's our base. We need to have an m, and we need to have an n, and we're ready to go. Whoops, already have an equal sign there. This is now log base 4 of 2 minus log base 4 of 5. And again, we know that this equals 1/2 from our last example. So we'll say 1/2 minus log base 4 of 5, and we're done. No problems. Let's move on to the last rule of the 3. We only have 3 of them here. So this one is called the power rule. It helps us know what to do when we're dealing with a power. Wow, you can't even see that, can you? Or it helps us know what to do when we have a power inside. Let's try one more time. Helps us know what to do when we have a power inside of a logarithm. And the rule tells us that this power can actually be taken outside, as you see here. So log base 4 of 2 to the 5th power, that the rule says that we can take this and bring it out. I guess I should identify each of the parts, right? Before I do that. So there's the b, where's the m, and I forgot the p. There's the p. So the p, which is the power, can come out front. That gives us 5 times log base 4 of 2. And again, we know this equals 1/2. Log base 4 of 2 equals 1/2. And we can replace the log base 4 of 2 with 1/2. And that gives us 5 halves. And we're done with that. So these rules, they're pretty slick. They're not too bad. Let's do something that's a little more difficult, right? I've got 3 more examples here. They're a little more difficult. They're not horrible, but they're a little more difficult. So let's check them out. Log base 4. First example, log base 4 of quantity x squared times the square root of x. So the first thing I want to note is this is really the same thing as y to the 1/2. Notice none of the rules we've discussed so far explicitly has a radical, meaning a square root or a cubed root or any type of root. So all of our rules deal with exponents. So change all of your radicals to exponents right away when you're doing these types of problems. And then you'll always have a rule to deal with the exponents. So if we rewrite that, log base 4 of x squared times y to the 1/2. Then we can use the product rule because we have the product of 2 things. Notice we have something here, a times b, something else here. Or if you prefer m and n like we used in the rule, we have 2 things multiplied here. So let's use our rule to expand. Log base 4 of x squared, the first term, plus log base 4 of y to the 1/2 power. So we used the product rule. And now we're going to use the power rule. So the power rule tells us that we can take the powers right and bring them out front. So now we have 2 times log base 4 of x plus 1/2 times log base 4 of y. And we're done. No problem. We just used the product rule and the power rule. Let's try another one. Let's see what we do here. So at first glance, it looks like I'm going to have to use the quotient rule because I have 2 things that are divided. I have a quotient, one thing is divided by something else. And then it looks like I'm going to have to use the power rule as well, because I can see a power here and a power there. So I'll use that. And then finally, I'm going to have to use the product rule because I have the product in the top. I have a x cubed times y. So we're going to end up using all 3 of our rules in this one. Let's see how it goes. So log base 6 of, we're going to use the quotient rule first. We'll have x cubed times y minus log base 6 of z squared. My z's have little hashes in the middle and my 2's don't. So if you're wondering how to differentiate the 2, that is how. Now we have used the quotient rule, so we can kind of check that off. The power rule, I think I'm going to use the product rule first to get rid of this first term. Has a product right there. That also wasn't what I wanted. I wanted a highlighter. Let's get rid of that first, and then we'll use the power rule last. So we have log base 6 of the first term, x cubed, plus log base 6 of the second term, minus log base 6 of z squared. So this first term then became these 2 terms using the product rule. So the product rule, we've used that, and now all that's left really is the power rule, because we need to get rid of that exponent and that exponent. So let's do it. Whoops. The 2 exponents come out in front. So we have 3 times log base 6 of x plus log base 6 of y. That term just stayed the same, nothing changed. But here we have the 2 coming out in front, so 2 log base 6 of z. And we're done. No problem. No problem there. Oh, I should probably put a check mark. There we go, power rule done. Let's move on to our last difficult example, and then we'll have our little summary of the rules and what we've done. So this kind of looks intimidating, right? We've kind of got a bunch of junk in there. That's a technical term, by the way, junk. It looks like I'm going to use, again, the power rule. I'm going to use the quotient rule. We'll use the quotient rule first. What else do we have to use? I'm going to probably use the power rule. No, I keep wanting to use the power rule. Maybe it's just because I need to write that down so I don't forget it. power rule. There you go, I wrote it down. And second, we're going to use the product rule. So we're going to use the quotient rule first because we have something here and it's divided by something at the bottom, and I want to kind of get rid of that before I start using the product rule to space things out. So log this, what is the base on this? I don't see a base. Do you guys see a base right here? No, I don't see a base there. So what does that mean? It's the common log. It's base 10. So log base 10 of the top, which is 100 x squared times the cubed root of 5 minus x plus, no, that's not the quotient rule, minus, that's the quotient rule, log base 10 of 4 times x plus 7 to the 6th power. Wow. Sound good? Well, the quotient rule, that's done. Let's see, we're going to use the product rule a bunch of times here. So in the product rule, we've got 1 and 2 and 3 things there. Here we've got 1, 2 things there. So let's start. Log of 100, because I don't need that. Maybe I should, because it doesn't, kind of looks funny without the parenthesis, because the 1 and the L's kind of look the same. Plus log of x squared plus log of cubed root 5 minus x minus, and we have a big parenthesis here. I'm going to put that in a different color so that you remember that it's there, because in the end we'll have to distribute that negative out front to all of the terms. Very common mistake. Log base 10 of 4 plus log base 10 of x plus 7 to the 6th power. Close bracket. So we need to distribute that negative. First, something else is that, remember, we should change all radicals to their exponent form. So this is going to be something to the 1/3 power instead of a cube root. And this, what is this? Log base 10 of 100. So 10 to the what power gives us 100? Well, that's 2, right? So this equals 2. And we can just write that in. So we have 2 plus log of x squared plus log of 5 minus x to the 1/3 power minus log base 10 of 4 minus, so we're distributing that negative through the second term as well, log of x, well, it's not a very good 7, x plus 7 to the 6th power. We are so close, so close. I believe our product rule days are over. So now we have to use the power rule. And we notice that this can come out front, this can come out front, this can come out front, and we'll be done. Here we go. So 2 plus 2 log base 10 of x plus 1/3 log base 10 of 5 minus x minus log base 10 of 4 minus 6 log base 10 of x plus 7. That's it. Kind of long. That was probably the most complicated, but we made it, right? We did it, and the power rules are all done. So what do we have left? Our little summary. Here are all of the rules that we have used. We've used the product rule, the quotient rule, and the power rule. That's it. Thanks for watching.